Alright, so let us see if we are live. Perfect. Okay. Hello, hi, my dear students. How are you all? I hope that everybody is in the best of their health. And I, Ritika, your chemistry educator, am back at the YouTube session of Unacademy. Right now, students, we are going to have a very important session today. We are going to discuss some of the very important things over here. Okay, and therefore I request you to be here and to participate in the session to the fullest, okay, so that you can achieve a maximum out of it. So what are we going to study today? We basically are going to have a study of gas laws, right? Now, if you were here yesterday, we had covered first session of our gas laws, and today we are going to move with this particular session, okay, and we are going to we are going to learn about the second part of our gas laws. Now, what are the things that we are going to cover today? I will be telling you, but before that, let's know a bit about me. So, I am Ritika, your chemistry educator. I have completed my engineering in electronics and communication, and right now I'm here teaching you chemistry. All right, now students, you can join my Telegram channel. The link is provided to you in the description box. If you need any assistance in your homework or your class notes, you can please join this channel, okay, to receive regular updates. Also, you can join the official Telegram channel of Unacademy, ICSE and ISC board. Okay, so just join it to receive all the updates of the classes, of the special classes, YouTube sessions, and all the ongoing offers here at Unacademy. Right now, let's quickly move further to see what are the things that we are going to cover in our today's class. So, as we learned yesterday that gaseous state, it is that state of matter in which the interparticle attraction, it is very weak. Why? Because the interparticle space, it is large enough, and because of this, the particles, they can move freely and randomly in all the directions, right? So this is our gaseous state. All the gases, they show same or similar kind of behavior, okay, under same kind of temperature and similar conditions of temperature and pressure. So it doesn't depend what their nature is, what their color is, or what their order is. They will be showing similar kind of behavior. Now, we already did Boyle's law yesterday. Okay, we learnt about some of the very important properties of gases, and today we are going to focus on Charles' law and the ideal gas equation. Okay, so let's quickly get started with this session. Now, Charles' law. Okay, it shows the relationship between temperature and volume. Okay, so first of all, if the question arises, which law shows the relationship between temperature and volume at a constant pressure, the law is Charles' law. Now, what does Charles' law states? It says that an increase in temperature at a constant pressure, it will cause an increase in volume, and decrease in temperature at constant volume, at constant pressure, it will cause a decrease in volume. Okay, so there was a scientist named Jacques Charles. He studied the temperature and volume relationship of the gases. Okay, now what is the statement that he gave? Okay, so he did some of the experiments, and it was found that if we are having any fixed mass of gas, it will be expanding or contracting by 1 upon 273 of its volume at 0 degree Celsius for each 1 degree fall or rise in the temperature. Now over here, what is the condition? The pressure, it remains same. So please try to remember the conditions, okay, whatever conditions are given to you. Kindly try to remember what the quantity is a constant and what quantity is changing. Now, if I talk about the statement of Charles' law, he told that if our pressure remains constant, so he told that pressure remaining constant, okay, that means the quantity which is constant over here, it is pressure, the volume of given mass of a dry gas okay, now let's see what happens over here. It either increases or decreases. Now what is the level of increment or decrement? By 1 upon 273 of the volume at 0 degrees Celsius for each 1 degree increase or decrease in temperature respectively. Okay. Now we will be seeing this particular statement through mathematical expression. All right. So basically, Charles' law, it states that if pressure it is kept a constant quantity, then the volume of any particular mass of gas that is given to us, it will either increase or decrease, and the level of increment or decrement it will remain to be 1 upon 273 of the volume at 0 degree Celsius, and it will increase for each 1 degree increase in temperature, and it will decrease for each 1 degree decrease in the temperature respectively. Okay, now let's go for the mathematical expression. All right, so first of all, we will be taking V naught, and what is V naught? It is volume of a fixed mass of gas at 0 degree Celsius. Okay, and we have taken V as volume of that gas at temperature. Let's suppose we are taking the temperature as T degree Celsius. And what is the condition that we have taken here? It is constant pressure. So according to Charles' law, what we can write that V is equal to V naught, this one, okay, plus V naught upon 273 into T. Now over here, what is the condition? We have taken P as a constant quantity. Okay. Now, if I solve this, what I can write, I can take V naught as a common quantity, and I will be writing 1 plus T upon 273. Okay, on solving it further, I can write it as V is equal to V naught, taking the LCM, 273 plus T upon 273. Okay, now here we have taken V is equal to V naught upon 273. Now see, I can write here capital T, where this T is equal to 273 plus small t. Okay. Now if I talk about any given mass of gas, so I'll be writing for any given mass of gas, we will be taking V naught upon 273 is equal to a constant quantity. Correct? So what we can write, V is equal to K into T. Now what is K over here? K is our constant. Okay, and if I turn it into proportionality, I can write V is proportional to T, or maybe V upon T is equal to K. Okay, so these are the two statements. Let's see how we have derived it. So we have taken V naught as the volume of fixed mass of gas at 0 degree Celsius, and V is volume at T degree Celsius. Okay. Now the conditions that we have provided over here, it is the constant pressure, and according to that according to Charles' law, we will be having volume is equal to V naught plus V naught upon 273 into T. Okay, taking V naught common and taking 273 as the LCM, we get this equation. Okay, and then if we take this as a constant, if we take T, capital T, which is equal to 273 plus T, okay, we can have this V naught upon 273 as a constant quantity. Okay, and by solving further, we can write V is proportional to, that is volume, it is proportional to temperature at a constant pressure. Okay, now we can give the second statement of Charles' law by this particular derivation, that volume of a given mass of dry gas it is directly proportional to what? To the absolute temperature. Absolute, that is Kelvin temperature. And what is the main condition that we need to remember over here? If pressure remains constant. Okay, so this is the statement that we can write for Charles' law. Now let us derive the Charles' law equation. Okay, now let's suppose we are having a gas, okay, that occupies volume V1 at T1 temperature, okay, and V2 centimeter cube at T2 temperature. Okay, now see, according to Charles' law, what did we derive? We derived that V1 it is proportional to T1. Okay, so what we can write? We can write V1 is equal to K up into T1. Now what is K? It's a constant term. Similarly, we can write V2 is proportional to T2, and that makes V2 is equal to K T2. Again, K is constant. Okay. Now from here, what we can write is, just a minute, yeah. So from here, we can write V1 upon T1 is equal to K. That is our first equation. And we can also write from the second one, V2 upon T2 is equal to K. Okay. Combining both of these equations, what we can write? We can write V1 upon T1 is equal to V2 upon T2 is equal to K. That is the Charles' law equation, and the condition that is provided over here, it is the constant pressure. Okay, so I hope that this thing is very much clear to you. Okay, now according to this particular equation, okay, if we double the temperature, what will happen? The volume it also will be getting doubled. Okay, and if we reduce the temperature by half, the volume also will be reduced. That means they are directly proportional. Okay, now let us try to understand the Charles law in terms of molecular motion. So if I talk about the kinetic theory of gases, what happens? The kinetic energy, the average kinetic energy of particles, it is directly proportional to what? The absolute temperature. Okay, now if the temperature of any gas is increased, okay, so if we are increasing the temperature of any gas, what will happen? The particles will start vibrating faster. Okay, so we can write that particles move faster, and when they are moving faster, they will strike the walls of the container more frequently. So they will strike walls of container more frequently. Okay. Now over here, what is the thing that if we keep the pressure as a constant quantity, what will happen? The volume, it will be increasing proportionally. Okay. So what we can say, at a constant pressure, the volume of given mass of gas, it is directly proportional to the temperature, which is the statement of the Charles law. Correct? All right, I hope that you might have understood this in terms of molecular motion. Let me revise it again. So if I talk about the kinetic energy, which is due to the virtue of movement, right? So average kinetic energy, it is directly proportional to absolute temperature. Now students, if the temperature it is increased, the particles, they will start moving much faster, and since they are moving faster, they will be striking the walls of container frequently. Okay, if we do not change the pressure, that is, if we keep the pressure as constant, the volume will increase. Okay, and that is what the statement of Charles law states, that at constant pressure the volume, it is directly proportional to the temperature. Hope that is very much clear. Okay, now there is a question, there can be a question which can be asked to you in your examinations, that why hot air is filled into balloons which are used for meteorological purpose. So over here there is Charles law, and that is the statement, or that is the thing that we are using. Okay, now if I talk about volume, okay, volume of gas, it is directly proportional to what? It is proportional to the temperature. Okay, now if I talk about density, the density, it will decrease. Okay, so density, it will be decreasing as the temperature increases. Okay, so that is the reason, okay, why we fill hot air balloon of hot air into the balloons which are to be used for meteorological purpose. So over here there is Charles law which we use. Okay, I hope that is very much clear. Next topic that we are going to pick up is absolute zero. Okay, so we know that V is equal to V naught 273 plus T upon 273. Okay, now if we want to find the volume at minus 273 degree Celsius, what will be our volume? It will be equal to, okay, so that will be equal to 0. Okay, so volume of any gas, it will be reduced to 0 at minus 273 degrees Celsius. So volume of any gas will be reduced to 0 at minus 273 degree Celsius. Okay, now there is a statement that if temperature of any enclosed gas, at 0 degrees Celsius, we are lowering it to minus 273 degrees Celsius, its volume will be 0. Okay, but is this thing possible? No, because gas, it is a state of matter, right? And being the state of matter, it obviously has to go, get some of the volume. Okay, it should be having a definite mass and volume. Okay, so if I talk about the temperature minus 273 degrees Celsius, this temperature, it is known as absolute temperature. And before reaching this temperature, all the gases, they either liquefy or they solidify. Okay, now this temperature is the lowest temperature that could be reached theoretically. Okay, any temperature below this level, it is not possible. And also this level is also not possible to attain practically. Okay, I hope that is very much clear to you. Now let's move on to the next important topic, that is conversion of temperature from Celsius to Kelvin and vice versa. So if I talk about the conversion, okay, if we need to convert from Celsius to Kelvin, what do we need to do? Just add 273. Okay, if I'm having 0 degrees Celsius, okay, so 0 plus 273, that will be equal to 273 Kelvin. Okay, now if I need to pick out for 20 degrees Celsius, so I just will add 20 to 273. That will be equal to 293 Kelvin. Similarly, if I want to go for minus 273 degrees Celsius, so what I will do, I will add it to 273, that equals to 0 Kelvin. Okay, now if I want to find the values, or I want to take the values from Kelvin to Celsius. Okay, I'm sorry. Okay, so if I want to convert from Kelvin to Celsius, what we will be doing? We will just subtract 273. So I'm having 0 Kelvin. What I will do, I will just subtract 273 and I will be getting the value in Celsius. Okay, if I'm having 273 Kelvin and if I need to pick out the value, it's 0 degree Celsius. Okay, so that is how we convert the values from Celsius to Kelvin and from Kelvin to the Celsius. Okay, now there are some things that needs to be noted over here. For absolute temperature values, we do not have any degree sign. Okay, so you cannot write 0 degree Kelvin. It is 0 Kelvin, 273 Kelvin, or let's say 373 Kelvin, anything. Okay, but not degree Kelvin. Okay. All right. Now let us move on to a very, very important information for all of you. That is the Unacademy's free special classes. Now students, these are the classes first of all which are available to you at the free of cost. That means you can watch these classes for free of cost. All you need to have is the Unacademy Learner app. Now you can talk to your teachers, okay, using the interaction okay options. You are having chat, you are having emojis. You can talk to your teachers, your educators in real time. Also you can ask the question to your educators. There is a question tab, okay, in which you can either type your question or you can even attach the image of your question and clear the doubts. Then we have live poll options. So these are the poll option for quizzes. Okay, you can we ask the questions by educators, you will be answering, and we also have poll leaderboards, which means you can compete with your friends. Next is the special class timetable. So we are going to have the very important periodic table on 10th of February. The timing of the class remains to be 5:15 p.m. And also on 12th of February, we are going to have a session on poll war. That is the question answer session on the periodic table. Okay. Next is the Unacademy subscription features, and why should you take the plus subscription? So see students, you can learn from the comfort of your home. Then you will be having unlimited access to all your courses. You will be taught by top educators of India at one platform, and also you will be having regular doubt clearing and your answer writing sessions. Next thing is your syllabus. It will be covered exhaustively. You will be under the mentorship of your educators. Also, you will be provided with all the study material in PDF format. After that, we have practice tests regularly. Okay, we have live test and batch courses. And apart from these all things, you get your daily practice section, weekly mock test series, live quizzes, daily MCQ, and subjective tests. So these are the things that you get on subscribing for Unacademy. Please go and subscribe. Okay. Now, if I talk about the prices are very affordable. You can first of all select the timing, okay, that you wanna take the plan for. You can go for 3 months, 6 months, 9, 12, 24, 48, whatever time duration you're comfortable with, and you can use my code for getting extra 10% discount. So my code is RITIKACLIVE. Please use this code to avail the extra 10% discount. Okay. Now moving on to next part, that is the gas equation. Now what is gas equation? It is basically a combination of the Boyle's law and the Charles law. Okay. Now if I vary both the parameters, that is pressure and temperature of any fixed mass of gas, we will be having a combination of Boyle's law and Charles law. Okay. So if I go for Boyle's law, I can write volume, it is inversely proportional to pressure. And if I talk about Charles law, here if I talk about Charles law, volume, it is directly proportional to temperature. Now if I combine both these laws, what I can write? I can write volume, it is inversely proportional to pressure and directly to temperature. So we can write, okay, so we will be having a constant quantity over here. So on transferring, I can write PV upon T is a constant term, right? Now, if there is any gas, okay, so if volume of a given mass of gas, it changes or it varies from V1 to V2, its pressure is changing from P1 to P2, and the temperature is changing from T1 to T2. So what is the equation that we can write? We can write P1 V1 upon T1 is equal to P2 V2 upon T2. Now this is the standard equation, and this is also known as the gas equation. Okay. Now, when to use this equation? So this equation is used when we need to calculate the change in gas volume when pressure and temperature both are changing. Okay. So please remember, when do we need to use which type of equation. I hope that is very much clear. All right. Now let us solve one question and then we will be moving on further. Okay, so our first question, it says that we have taken 120 centimeter cube of a gas at 27.3 Kelvin. Okay, now what are the changes that we are making? We are changing the temperature and we need to find volume if pressure is constant. Okay, now let us see what are the values given to us, okay, and how we can put in the equation to find the answer. So see, whenever we are going for these numericals, okay, we will first of all be putting or writing all the values that are given to us. Okay, so just write all the values. For example, over here, what are the things that are given to us? We have been given V1, that is equal to 120 centimeter cube. Just a minute. So that is okay, Divnit. Okay, yeah, Divnit, what happened? Could you please tell me? So V1, it is 120 centimeter cube that is given to us. And T1, it is given to us as 27.3 Kelvin. Okay, now here it is told that temperature it is raised to 0 degrees Celsius. Okay, so T2 it is raised to 0 degrees Celsius. We need to convert it into Kelvin. So what do we do? Just add 273, so that makes it 273 Kelvin. Okay, and we have to find what? Volume. So V2 is unknown. Now, pressure, it is the constant quantity over here. So what law or which law will be using? We will be using Charles' law, which says that V1 upon T1 is equal to V2 upon T2. Okay. Now, if we substitute the values over here, we will be getting 120 upon 27.3. That is equal to what? V2 we have to calculate upon 273. Okay. Now if I transfer it, I will be getting the equation 120 into 273 upon 27.3 is equal to V2. And if I solve it, I will be getting V2 as 1200 centimeter cube. Okay, so that is the answer of this question. We have applied Charles' law and we have taken out the answer. Okay, now next let's talk about the another important thing, that is the standard temperature and pressure. Now students, if I talk about the volume of any gas, okay, so it is changing with change in temperature and pressure. I'm sorry. So volume of the gas, it is constantly changing with change in temperature and pressure. So that is why it is necessary to choose a particular or standard value of temperature and pressure, okay, to which we can refer the volume of gas. Okay, so we have taken the standard values of temperature and pressure. Now if I go for standard temperature, it is taken as 0 degrees Celsius or 273 Kelvin. And if I talk about standard pressure, it is taken as 760 millimeter of mercury or 76 centimeter of mercury or 1 atmosphere. Okay, so these are the standard values that we refer to. Hope that is very much clear. I hope there is no confusion up till here. Okay. Now let us solve some of the numericals from this particular gas equation and Charles' law. Okay. All right. So we will be starting with the first numerical. And the first question, it says that 1 liter of a gas at 10 degrees Celsius is heated till both volume and pressure are tripled. Find new temperature. Now see over here students, there are what are the values given and which equation we should be applying. So for that, first of all, what are the things that we are going to do? We are going to write all the quantities that are given to us. Okay. All right. So first of all, we will be writing the initial condition. Okay. So what are the conditions that are given to us? Please pay attention over here. So P1, it is given to us as P because it is not actually given. So we will actually take it as P. Okay. Then V1. V1, it is given to us as 1 liter. So we can just write as 1, okay, liter. Kindly mention the units with it. Okay. Next is T1. So T1, it is equal to what? 10 degrees Celsius, and we need to convert it into Kelvin. So just add 273. Okay. Now that is equal to 283 Kelvin. Okay. I hope that is very much clear. Now we will be going for final conditions. Okay. Now what are final conditions? Now pressure, it is told that it is tripled. So we will be taking it as 3P. V2, it is taken as again 3 liter. Why? Because it is also triple and we need to find the temperature. Okay. Now, if I talk about the gas equation, what it says P1 V1 upon T1 is equal to P2 V2 upon T2. Okay. Now, what is our P1? We have taken P. Volume 1 is 1 and temperature 1 was 283 Kelvin. Okay. Then what is P2? It is equal to 3P. Volume 2, it is 3 and T2 we have to find out. Alright. So if I transfer the values, I will be having the equation as P into T2. Okay, so T2 we have to find out. Okay, so what we will be doing, we will be transferring it and we will be getting the equation as 3P into 3 into 283. Okay, and P into 1. Okay, so what is the answer that we will be getting on solving it? It will be 2547. Now this value, it is taken in Kelvin. So it's very important to convert it into degrees Celsius. So 2547 minus 273, it will be equal to the value in degree Celsius. So it will be equal to 2274 degree Celsius and that will be our correct answer. Okay, now let's move on to the next question. Okay, so the next question is pressure of a gas at STP. Now what does STP stands for? It is standard temperature and pressure. So pressure of a gas at STP is doubled and temperature is raised to 546 Kelvin. Okay, now what is the new volume? Now again we need to put in the values which are given to us. So let's see what are the values which are already given to us. So P1, it is given to us as 760 millimeter of mercury. Then we have been given temperature 1, that is equal to 273 Kelvin. Why? Because over here the conditions are standard temperature and pressure values. Okay, so we will be taking those values. Okay, then V1, it is not given, so let's take it as V1 only. Okay, so what are these? These are our initial conditions. Okay, next we will be moving on to the next condition, that is P2, which is given to us as 2 into 760 millimeter of Hg, that is pressure, it is doubled, right? And temperature, it is raised to 546 Kelvin. Okay, and we have to find out the volume, that is V2. Now how to find out? Again, put the values in the gas equation. Okay. Now, putting in the values, we have P1 that is equal to 760. V1 is not given, and T1 it is given to us as 273. Now, next P2 it is given to us as double. Okay, so we will be writing 2 into 760 into V2, and what is T2 we have to find out. Correct? Now, by this equation, if I transfer the values, okay, I will be getting what? V2 is equal to V1. Okay, so final volume, it will be equal to what? The initial volume. That means the volume remains same. Okay, I hope that is very much clear. All right, so we just missed one thing. There is 546 that we needed to write over here. Okay, yeah, and the volume it will remain same. Okay, I hope that is very much clear. There is no change in the volume that is happening. Okay, all right, so I hope these things are very much clear to you. Let's pick out some of the more important questions and then we will be moving on to next part. Okay, okay, just a minute. All right, your next question says, okay, so we have taken 87 centimeter cube of moist nitrogen. Okay, it is measured as 9 degrees Celsius, and what is the pressure? 659 millimeter of mercury pressure. Okay, now we need to find the volume at standard temperature and pressure. And what are the more things which are given to us over here? We have been given the vapor pressure. So the vapor pressure of water at 9 degrees Celsius is 9 mm of Hg. Now, what is the use of this particular line? Because we didn't have any question like this, right? 9 mm of Hg and vapor pressure. So, what is the vapor pressure? Let's discuss about the vapor pressure first. Okay. Now, when any gas it is collected over water, okay, it is moist and it will be having water vapor. Okay. Now the total pressure which will be exerted by that particular gas, it will be equal to what? The vapor pressure and the actual pressure of the dry gas. Okay, so over here we need to subtract the vapor pressure to get the actual pressure of dry gas. Okay, so before moving further, let me tell you how to have the pressure. So total pressure, it is equal to what? Pressure of gas plus vapor pressure, that is water vapor. Okay, now if we need to pick out the actual pressure of any gas, it will be equal to what? It will be equal to the total pressure minus the pressure of water vapor, that is okay. So this is how we need to solve this question. Okay, now let us see what are the values that are given to us. So first of all, we need to take out the pressure of nitrogen, okay, in the dry form. Okay, now over here what was given to us? The total pressure was 659 millimeter of mercury. And if I talk about the vapor pressure, it is equal to 9 millimeter of mercury. Okay. Now, if I talk about the pressure of dry nitrogen, so pressure of gas, it will be equal to what? 659 minus 9, and that will be equal to 650 millimeter of mercury. Okay. Now from here we will be writing the values which are given to us. So P1, it is provided to us 650 millimeter of mercury. Volume 1, it was given to us as 87 centimeter cube. Okay. And T1, it was given to us as 9 degrees Celsius, which is equal to 273 plus 9. Okay. In the Kelvin. Okay, just add 9 with 273. We have to convert it into Kelvin whenever we are going for the solutions. Okay, it should always be in the absolute temperature. Okay, so now the temperature 1 is equal to 273 plus 9, that is equal to 282. Okay, Kelvin. Now, what are the second values which are given to us? We have been given P2 is equal to 760, okay, STP. So 760 mm of Hg. Then V2 we have to find out, and T2 of course it is 273 Kelvin. Hope that thing is clear. Now if I go for gas equation, it is P1 V1 upon T1 is equal to P2 V2 upon T2. Putting in the values, what is my P1? It is 650 and T1 is, okay, it is 87. Okay. Yeah, V1 is 87. So 760 into, 650 into 87. Just a minute. Okay. So over here, P1, it is 650. V1 is 87. And the temperature one that we have taken, it is 282. And then P2, what is given to us? 760. Into volume 2 we have to find out, and temperature it is 273. That is the standard temperature. Okay. Now going on for transferring the values, 650 into 87 into 273 upon 282 into 760. If we solve it, the volume it will be coming out to be 72.03 centimeter cube. So this is the volume of dry nitrogen at standard temperature and pressure. Okay. Hope that is very much clear to you. I hope everything that we learned is clear to you. Now, talking about Unacademy Prodigy. So this is a test for class 7th to 12th learners. You can win the scholarships and some of the amazing prizes while testing your mental ability. Now you can enroll yourself right now for free of cost. This test now it is scheduled to happen on 13th of February. Okay. Now students, your test schedule is as it's listed. So all the students of grade 7 to 10, your test it is scheduled on 13th February at 12 noon. So kindly make sure that you attend these tests because you will be getting many exciting prizes and much scholarships. Okay. Now, talking about the prizes, you can win a 20 lakh college grant. The first prize, it is MacBook Air. Then the rankers, second and third will be getting the Apple iPhone. The ranker 4 and 5 will be getting Apple iPad. The 6 to 40, if your rank falls between 6 to 40, you will be getting an Amazon Echo Dot. The rankers from 41 to 100, they will be getting Amazon vouchers. Okay, next talking about the scholarship slabs. If your rank falls between 1 to 10, you will be getting 100% scholarship. If your rank falls between 11 to 25, you will be getting 75% scholarship. If your rank is from 26 to 100, you will be getting the 50% scholarship. Similarly, if your rank goes between 101 to 200, your scholarship is 25%, and if your rank is 201 to 500, your scholarship is 15%. Okay. Next is the very important information about the upcoming batches. So students, for the preparation of your term 2 examinations, we have come up with the amazing crash course batches. Okay. Okay, there's a mistake. It is for grade 9. Okay, so this is the batch for grade 9 ACERS all subject batch in English. Okay, it has already been started from 7th of February. Now over here physics is taken by Ayushi ma'am, biology is taken by Shikha ma'am, and chemistry is taken by me. And students, if you are going to subscribe for grade 9, you are going to get the subscription of grade 10, 11 and 12 absolutely free. So students, it is a very amazing opportunity. Kindly avail this opportunity and take your preparations to the next level by Unacademy Plus. Now, students, if you have any confusion or if you are having any problem, you're confused about your preparation journey, or you have some queries about your subscription, or you want to know about the latest offers that are going on here, you can just call on this number, that is 85858585 and 85. Okay, now you can call here and there will be a counselor who will get in touch with you and will be solving all your queries. Okay, also you can use my code RITIKACLIVE to avail extra 10% discount in your plus subscriptions. Okay, so students, I hope that you might have understood everything that we have covered today. We covered the Charles equation and the gas law. Okay, the gas equation. I hope that everything that we learned today was understood. Okay, there's a request, you can subscribe to the channel of Unacademy to not miss any update from here. You can also press the bell icon. Okay, and you can like and share the video. Also, please join the Telegram channel to receive the updates regularly. The link is provided to you in the description box below. Okay, so we will be meeting in the next class, students. Okay, till then, keep studying, keep learning, and take your preparations to the next level by Unacademy Plus. Thank you very much. Let's